Well, thank you for the introduction. So as the name implies here, this is basically going to be about how to secure cloud-based product development. But before we start, maybe a few words about myself. So I've been working in the software industry for a few years now. I started out as a software engineer originally, but then transitioned over into a security role. And I'm currently working also as a security engineer, securing an as-a-service platform, which is currently running on 2 cloud-based platforms. And this talk is a kind of a summary of the things I've learned over the years, both in my current job, but also in my previous job, where I've seen quite a lot of different cloud-based products. Okay, so imagine you're a security engineer and you're starting a new job right today. You're working for the startup called ACME, and they've hired you specifically to build up their cloud security program. That means you're the first person who really thinks about security from a holistic perspective, and hopefully you knows what you're supposed or what they are supposed to be doing. And when we're talking about product, their product is what you see very often these days. On the one hand, it's an as-a-service offering, can be platform as a service or software as a service. It's running on those usually well-known cloud provider platforms. And their technology stack is also something you see very often these days. So the applications are packaged into containers. The containers are being deployed and executed by Kubernetes, and you have some additional cloud service around it that you need for compute instances, for storage services, and so on. So this is not a thing, let's say, unusual that you can see in cloud space these days. So the question is, where do you start, right? Security is a huge topic, and you can't do everything on day one. You have to somehow prioritize and think about what can you do at the beginning and what can you do later. That means at the beginning, we want to go for some easy wins, right? Things which are so-called low-hanging fruits, but at the same time have a high security impact in terms of improving the security posture of the product. So how can we do that? And that's basically what this talk is about. How can we define a security roadmap that somehow starts in a relatively easy way and then scales up over time? So security activities that I'm going to present on the next slide are grouped into different phases. Phase 1 is like the absolute basics that really everyone should start with. And then starting from phase 2, we're going to have more topics that might only pay off in the medium term. Whether something should be in phase 2 or 3 or 4 is a little bit, let's say, it's always biased. It depends on what's your background, right? For people here who have a web application security background, they might complain, hey, there should be more web application security in there. I've done a lot of work on the infrastructure space, so obviously it's maybe a little bit more biased towards infrastructure. It also depends what's the current security posture of a company, and so on. So long story short, while phase 1 should really apply to everyone, afterwards it depends what's the best approach for you, but it's more like to give you some inspiration. All right, so what are the security phases? I've defined 4 phases, and if you do all of those, you already have achieved a quite good security posture. Doesn't mean you're completed, but you have, I think, some good achievements. Phase 1 at the very top, as I say the basics, I'm going to talk about those in detail. Phase 2, these are already some additional topics. I will briefly cover them, and unfortunately, regarding phase 3 and 4, I don't have enough time today to talk about that, but I have backup slides if anyone should be interested. The idea is, phase 1, I said the basics. Phase 2 is some topics that are, again, easy wins, but at the same time, should pay off in the medium term. Starting from phase 3, we have some topics that are really either need a lot of effort or are only going to pay off on the long term, especially for phase 4. So I say that I don't have much time, so let's get started. Phase 1, and this is actually the very first task that you have to do at the beginning. So remember, you are coming in, it's your first day, and you have no idea what you're dealing with. You don't know how to secure something if you don't know what you have. The first idea is you have to get an overview of a cloud environment. Which cloud providers are you using? How many accounts do you have? Do you have a segregation between production and non-production environments? And most importantly, you need access to those accounts and start looking into them. What kind of infrastructure is deployed in those accounts? What kind of services are being used? And most importantly, how are those services configured from a security perspective? We'll talk about that a little bit later. If you're only dealing with a handful of accounts, so in AWS calls it accounts, on Google Cloud it's called projects, but it's basically always a cloud environment. You will easily run into the scalability problem. If you have to deal with dozens or maybe even hundreds of accounts, you can't go over them manually, right? Can you log in into every individual account, start clicking around on the dashboard? That's not going to scale. So you need some form of automation. And there's a lot of tools out there that can really help you with that. And these are all open source tools that I've listed here. And that list is not even complete. Which tool is the best one for you depends on what you prefer working with, and also how many cloud platforms you have to cover. Some are multi-cloud, some are only supporting one individual cloud firm, in particular AWS, because it's the most widely used one. It also depends how you want to handle the tool and what kind of output. Are you fine with reading JSON output, or do you need some tabular output? Do you want to process this further? Either way, I personally have used TeamWeb a lot because it's super flexible and supports a lot of different platforms, including software as a service platforms like Cloudflare or GitHub. But it is, you can use that to automatically obtain data from your environments and specifically kind of select what kind of information you are looking for, what kind of misconfigurations maybe. And that gives you a basic idea on how serious security was taken in the beginning, right? If you already see some bad things there, you know, oh, this is not a good start. Otherwise, if it's looking roughly good, you know, okay, I don't have to start from the beginning. Either way, so I've used this tool to collect a lot of information and then have to start looking for this information. And the very first thing that I usually want to do there, that's step 2 now, parameter protection. And in the cloud, we have 2 parameters. The first parameter is identity and access management. And I think this is a big differentiator of cloud compared to on-premise systems. Because the cloud provider API is the thing that's used to access your cloud environments. And that's reachable over the internet to everyone. The only thing that keeps you from getting breached on the cloud provider level is to keep your credentials secure. That's why it's so important to really look at what kind of credentials are currently being used. So we have to differentiate here between human users and service accounts. Human user, we know you have a form or a login form, you log in with a password maybe, then you get in. That's what, at least in AWS, is supported actually. You have console login with a password, or if you need API, programmatic access, you have an access key. Both are long-term credentials that do not expire and you don't have to rotate them, which means that's a problem. And actually, if you look into the publicly known security incidents of AWS customers, very often the initial access vector for the attacker was a leaked access key, like somebody committing it to a public GitHub repo. So you have to somehow get rid of those access keys, or more generally, long-term secrets. So for humans, there's no need to use it anymore because you can set up single sign-on. The idea is you use single sign-on and then the human user can obtain a short-lived token to access the cloud provider interfaces, including the API. And as we're talking about single sign-on, we should obviously be using multi-factor authentication as well these days. And particularly for the production environment, I think it's worth investing in the physical authentication tokens as well, like Fee2Do, which I think are very cost efficient. Now, single sign-on is not going to work with service accounts, right? We need something else there. I see quite often that you have an application that's running on, for example, Google Cloud and needs access to the Google Cloud API. That means your application is going to need a credential. People sometimes use those long-term secrets just for that. But you don't have to do that anymore. Because the better way is to obtain a short-lived token from a cloud provider metadata service. So in the case of, for example, AWS, if you're running applications inside Kubernetes, they have a feature called IAM roles for service accounts, which means you sign a role to your application. That means the application can get a short-lived token from the cloud provider metadata service. There's no long-term secret involved anymore. And those tokens usually only have a lifetime order of magnitudes of hours. It's the same on Google Cloud. The feature there, if they're using their managed Kubernetes service, is workload identity, which works basically the same. You have an application running inside Google's managed Kubernetes. You assign a role to it, and then you can obtain a short-lived token from a metadata service. So that works very well if your application needs access to the cloud provider API of the same platform. Things are a little bit more complicated for cross-cloud provider access. Like application running Google Cloud needs access to AWS API or the other way around. Until maybe 2 years ago, the only solution was you generate an access key in AWS, you export it and basically import it into your application on Google Cloud, which means you have a long-term secret that you can leak again. Luckily, you don't have to use that anymore because you can now use identity federation for service accounts. So if I continue this example, my application running Google Cloud obtains the token from Google Cloud as described here. Then this application starts calling over to AWS and authenticates with the Google Cloud token, which is accepted by AWS, and they will issue an Amazon token for that. Now my application can use that Amazon token to access the API. And all of those tokens are again short-lived. And this works because on the AWS side, I will set up saying, hey, if somebody shows up with a Google token that was issued by Google and is assigned to a particular identity at Google, then this person can now get an AWS token. Meaning that I've completely eliminated the need for long-term secrets on both AWS and GCP. On the same works with other cloud platforms as well, which means I've reduced already the risk of leaking long-term keys, which is often a problem for many people or companies. So that was about access keys or credentials. Another issue I see very often at the beginning, you have to sign IAM privileges, right? You have a token, that's one thing, but you also need to define what can I actually access with the token. And people often then do assign a lot of privileges, right? Because it makes life easier for them. So it makes a lot of sense to look over all those IAM policies and basically see if you find these kind of situations where people use wildcards, that means can do anything, to cut them down. So this is basically least privilege principle that you have to review. That was the IAM parameter. The second parameter, that's basically the same that we have in classical non-cloud on-premise networks, which is the network parameter. So what I have to look for is do people actually have a network architecture, meaning public DMZ and private zones, where most stuff should be deployed in the private zones, and only the bare minimum should be in the public zone with public IPs reachable to anyone. And the second thing is firewall reviews. That happens really often, that people start opening up ports to the internet. Internet means, again, to anyone. And you have to look in particular for things like OpenSSH ports. Usually when you open up an SSH port with the internet, it takes only a few hours and people will start brute forcing you. And then if you have a password like CentOS, then you will be breached. Now, what I've said is we're going to basically look at the output from the tool and go over it manually, right? So today everything might look fine. Maybe next week it's not fine anymore because somebody has already started opening up firewall rules or generated access keys. So we cannot manually go over that every single day or even once a week because that's not going to scale again. So we need some way of automatically monitoring our entire environment for this kind of security violations. And the solution to that is called Cloud Security Posture Management, which basically is just a piece of software that's going to look into your cloud environments by calling the APIs and checking if anything violates your predefined security policies, like what I've said before, right? Either you have access keys there, somebody has opened up the firewall rules, somebody has a storage system that is publicly reachable to anyone. And there's different solutions for that, how you can implement it. Option one is cloud provider service. They have everyone supports that basically has a solution for that. There are also third-party offerings for that. For example, software as a service platforms. Basically, you grant them read access to your cloud environment and they can monitor everything and then tell you or raise alerts if something goes wrong. Some also offer the tool itself, so you just get a software package and you deploy and operate it inside your own environment. There's the advantage that you still have full control and don't have to grant access to a third party to your environment. Or third option, open source tools that you can use to build basically your own cloud security posture management. Cloud Custodian has been around for many years. I think it was one of the first tools, and it's very popular, I think, with some people. Steampipe that I mentioned in the beginning for inventory, you can also use that for cloud security posture management. Although at some point, depending how large your environment is, you might run into scalability problems. But the idea is this allows us to monitor everything automatically. And once a violation is detected, you get an alert. And you can run this maybe, depending on the solution, in almost real time or like once a day or once a week. So next part. Sooner or later, you're going to have a security incident. But it's minor or major is a different story. But when you have that happen, you have to start investigating. And investigating means you have to go over your log files, right? Because without that, you cannot really do a proper investigation. What I found is the easiest way to do that, to set up a central log data sink and to just dump all your log data in there, just for storage at the beginning. And the most cost-efficient solution for that is to use one of the storage services like Amazon S3 and so on. Because it's easy to set them up. You can drop as much data in there as you want because there's kind of no limit, and they're very cost-efficient as well. You can use a SIEM, but that can become very expensive. depending on what kind of solution you are using, because of the huge amount of data that you're dropping in there. And the first kind of log data that we feed in there is going to be the cloud provider logs. If you have a breach on the cloud provider level, that means the attacker is going to call the cloud provider APIs. And those calls are going to show up in the management API logs. That's why it's important that you activate forwarding these API logs into your central log data sink. You make sure nobody can mess around with that, so you need access control on that. Now we are just storing data, right? At some point, when you have a security incident, you might have to query this data. And depending on how large your environment is, we're talking here about querying gigabytes of data. 10 gigabytes, maybe even 100 gigabytes. So you're going to need some infrastructure for that. But as I said in the beginning, our scenario is you're the first and only security engineer. You don't have the time to maintain or operate infrastructure for that. So my recommendation is here to go serverless. You have these services, that data lake querying services like Athena or BigQuery. The same should exist for Azure, that allow you that. They're very easy to set up. They don't need any maintenance at all, and you can query them also in a relatively cost-efficient way over your entire data. Basically, the more data you query, the more you have to pay. But if you don't query that often, it makes sense to do that. It's not a lot of effort to set up. Right, then incident response. As said, when the incident happens, you need to be prepared. And it's a good idea to do that in advance, right? How does your basic process look like? You go into the store, need to store evidence somewhere, so you need a dedicated location for that. Makes sense to track incidents in the issue tracking system, and you need to find in advance who's your contact person for what topic, right? Operations, you have to talk to them. If customer data is affected, you have to reach out to your customers, but you're not going to do it yourself. You need someone from customer support for that. So that's important to define who's your contact for what topic in the beginning before something happens, so that by the time you have the incident, you're ready to go. And finally, vulnerability management. I think that's a very old topic. It's not too different in cloud. The only difference is we have vulnerability management on two levels. We have to scan for vulnerabilities first on the container level, which also includes our application dependencies, and on the host level, meaning the host machines where our containers are being executed. There are open source solutions available for that. Anchor and Claire working very well. They work primarily for containers. Host machines is a somewhat more complicated story. I don't know any reliably available solution for that on the open source space for vulnerability scanning on the host machines. And one more thing, CI/CD based scanning makes a lot of sense, yes, but it's not sufficient, right? If I build a container image today, I scan it today and it has no vulnerabilities, this assessment might not longer be true next week. So I need continuous vulnerability scanning. That's something some people forget about that. And identifying vulnerabilities is one thing, fixing them is another story. We have to write down SLAs for that with engineering and agree on something like 1 week to get a critical or high vulnerability fixed or something like that. Well, and that's already phase one. This should give you a base standing, but that will take you at least weeks, maybe a few months, depending on how much in-company support you will get for that. After that, we'll continue with phase two. And then the first thing is defining the security baseline. As a security engineer, usually you know what you should do, right? But that's usually not clear to engineering. So it's very important to write it down, define what are your expectations towards engineering for that. And you don't have to come up with this yourself. There's a lot of good stuff out there, in particular the CS benchmarks. They have basically security best practice not only for cloud providers, but also for Kubernetes, for Docker images, and so on. It makes sense to just adopt those standards. Once I've written down my baseline, I need to set up the monitoring for that, right? To see if people are actually following my security baseline. And this is where I can use the cloud security posture management, because I have to implement my baseline basically in there to look for violations of my baseline. Then another easy win, Kubernetes or container deployments. A lot of people, when they run the application inside containers, those applications are running as root. I've seen this so often, I think I don't know what's going on there, but nobody's thinking about it. There's a very easy way to override that. In Kubernetes, you have a so-called security context object. And there you have a parameter called run as user that allows you to override that. You just specify in your deployment, no, run this as a non-privileged user, and then it's no longer running as root. This is super easy to implement. And there's a lot more security features in Kubernetes that you can use. Finally, also something that people sometimes miss, if you have two applications running in the same Kubernetes cluster, there is no network isolation between those applications. Application A can always reach application B and vice versa. That's just the way vanilla Kubernetes works. The way to fix that is to use so-called Kubernetes network policies, which are usually never enabled by default. You have to explicitly enable them and start deploying network policies, which means basically it's a firewall rule that applies inside the Kubernetes cluster. Then again, as I said about using this run as user option, how can you be sure that people are actually using that? You have to, again, set up the monitoring for that. That means you have to extend your cloud security posture management to also monitor your Kubernetes clusters to see what people are deploying there actually and how. A very different topic. So security in cloud usually means you have a scalability problem. That means you need to automate as much as possible. For that, you're usually going to need some tool, right? So for example, I want to run a dynamic application security testing once a week. I want to run some board scans maybe every day. Same with credential scanning maybe. So I need some platform that allows me to define what tool am I using, how I'm going to call this tool, how I'm going to process the output, and where do I push this output. Then I need a time schedule for that. This is what workflow orchestration engines are very useful for. Again, there are cloud provider services, serverless, that allow you to do that. There's also two Kubernetes frameworks for that, which is Argo and Tecton. I personally used a lot of Argo workflows, but functionally it's almost the same as Tecton, so it doesn't really make a difference. Or if you don't have that much security automation, of course, you can just spin up a virtual machine with a cron job on it that schedules everything. A lot of this is reactive, right? It's how do we get things in a more proactive mode? This is not even cloud specific. I have to hook into the software development lifecycle. That means I need to be involved in the design phase. Otherwise, I will always keep running after people to get things done. And yeah, the pen test, kind of obvious, I think. Right. And that's phase 2. And then in theory, I can continue with phase 3 and 4, depending on what I want to do and so on, and how the security posture is now. Now, before wrapping up, some final thoughts. So our startup ACME is dealing with business customers. And there are some customers that will say, I really like your service offering, but I will only do business with you if you have a security certification, like ISO 27000 or SOC 2 or something like that. Now, I'm not going to get in topic if those certifications are going to improve your security posture, but I think that's the wrong way of looking at it. You can use those programs to actually push for your security again or to get things done. Because if somebody asks you, hey, why do we have to do this? You say, well, we need this for SOC 2. And if we don't have SOC 2, we will not win that customer. So that will help you a lot because nobody's going to argue about bringing in more revenue, right? So you've changed security of now being a business enabler, which is making discussions a little bit easier in my experience. Yeah, and finally, that's more a culture question. How are you approaching security, right? I mean, security is a very cross-functional role. We have to deal with a lot of people, right? You talk to customer support for incidents, and as we are talking about product security, we are dealing a lot with engineering. You have to build a relationship with them, and that means, are you going to be a guy who's just going to make trouble for them and is going to blocking them all the time? Or are you more seen as a valuable support function? Because this can really influence a lot on how whether they are willing to work with you or not. Right. And before I wrap up, I'm not the first person to think about how to do this in a structured way. There's a lot of very interesting material out there in terms of talks and also documents. I highly recommend going for this if you are interested in this topic. Well, and that's it.
Cool. Thank you very much, Christian, for the interesting talk. I think the one key takeaway is that as a security person, you should not try to be the blocker, but more like a valuable resource. That's a very good recommendation, I think. Are there any questions from the audience? Please step forward and shoot out.
Hi, thank you. Great talk. I was wondering, what is a good way to get more support by the engineering team and everybody in the company for getting a better security system?
It's a tough question. Well, I think there was one of a slide that I've removed for time reasons. I think you need management support. If management doesn't care about security, then things are going to be difficult. And the other thing, I think if you work with different teams, there are also people who are for security and some people who don't care. It's important to identify basically those people who are interested in security, because those are going to be your allies. And I think these are basically kind of security champions that they can try to push.
Thank you.
Hey, question about the last thing you touched on security culture. Yeah, they building relationships with other departments and not being a blocker. Sounds great until you hear that someone is trying to put an RDP password logon machine on a public IPv4 address. So where's you have the one side where everybody here at least thinks they have to put the foot down, but then you kind of go against that. How do you keep balance?
Yeah, so there's an interesting talk from Netflix, and their security culture says trust but verify. Their idea is they have the monitoring in place. If one team screws up, the monitoring will show it up immediately, and then they go to those people and tell them, hey people, you have to fix this. And they have dashboards that show how well teams are doing. They're kind of playing the teams against each other, saying, oh, this team is really doing well. You're more like down there. Maybe you should really do something. This is kind of an intrinsic motivation for other teams. That works for Netflix. I don't know if that works in other places too.
All right, thanks.
So actually regarding working with other departments from my experience, it helps. So this also notes with others when you accept that they have problems or issues. When you take them serious, from my perspective, they take also serious if you see that you're competent. Most of the time, what developers and engineers think, okay, someone comes around and he wants something, but we have other problems. So that's just a remark. I have two questions. First, you talked about setting up a perimeter. Mm-hmm. There's nowadays this thing called zero trust model, and there are a lot of guys that are saying, oh, everything has to be secure with zero trust. What do you think about that one? Would be my first question.
Yeah. So, I mean, it's a buzzword, right? Zero trust. I mean, I'd say...
The thing is, with the parameter, you kinda... So, if you had said in a later phase, you remove the parameter and do everything, for example, in a VPN or separate control and data plane, then I would say, okay, for the first step, parameters are good. But in my experience, especially still in cloud, people are doing, oh, I'm in the trusted parameter, so that's no problem anymore.
Right. Well, I mean, I think it's not going to, I'm not going to say this will still just remove the network parameter. You still have it, right? As said in Kubernetes, inside this idea, you are inside a trusted island, then everything is good. I think zero trust for me is the opposite. This means microsegmentation. And microsegmentation for me includes network parameter, maybe on a smaller level, but still it's there. And I think the IAM is actually in the cloud is very easy to do zero trust for human users. You can say you can set up IAM policies that say you're allowed to log in, but only Monday to Friday and only from a particular IP address range, for example. I think in the cloud is maybe the easiest place to implement zero trust.
Yeah. The second question, I was a little bit surprised that you did not talk when talking to the developers about the supply chain stuff, because especially I'm more of an infrastructure guy myself, but the thing is, with the packager situation today nowadays, I would say, okay, we have to really look where the developers they're getting their software from and their libraries. So, in which phase would you say is that? Later on?
It depends.
Okay.
So, well, I mean, if you had problems already in this direction, you should pull this into phase 3 at least, obviously, right? I mean, vulnerability management is covering this a little bit, but not completely, obviously. But I'd say I probably put it into phase 4.
Okay. Cool, thanks.
Over time a bit already. Is it a quick one or?
Yeah, maybe I can do a quick.
Cool.
Thanks again for the presentation. So I'm wondering, so here you're starting with the assumption that you have a full access into the network, to the system, visibility. How much would it be different if you have a partial or a non-view? You know, if some part is outsourced or you're part of the team that is actually doesn't have access to the entire system?
Well, if you have no view, you have a problem, right?
I know.
I mean, you can still do the parameter, right? Scan that, but that's it. If you have a partial view, it depends. I think a lot. What do you have access to? Like, do you have still access to Cloud Provider API, and that's it? Or do you also have to have access into host machines or things like that? I think you should always go for access as a security team, because actually most cloud providers will give you a dedicated security read-only role just for that purpose. It's called security auditor role. And you should always go for that. I think if you don't have that, then you can't do work. I mean, it's impossible.
Cool, great stuff. Thank you very much, Christian. Thanks to the audience for the good questions. Another round of applause.